was trying to think if we needed to work on something else, but I guess it's
Lesson 92. Derivatives of inverse functions. So when you see within a problem the derivative of the inverse, or you want to find the slope of the inverse, or something about inverse and derivatives, here we go. Okay? So, a few things to remember about inverse functions. First of all, go back to your algebra days. In order to find an inverse, we take our x's and our y's and we flipski, is that the word back there? I was going to say swip swap, I don't know. Whatever you want to use there, but we switch our x's and y's with each other. And an inverse function is symmetric across the line y equals x, which y equals x is that perfect diagonal line. Okay. We begin by writing them implicitly, not explicitly. In other words, when you first write an inverse and you switch your x and y, they're not usually solved for y. They're not usually y equals. So that's written implicitly. And then we do usually then make them explicit and solve for y. And then the ordered pair xy for the original function is the ordered pair yx for the inverse function. Okay? So, and there's a little note over there. Remember, xy becomes yx for the inverse function. That is an important one with what we do today, because you won't always have, I sometimes feel in these, like looking at them, I feel like I don't think I have all the information I need. But I do have it. It's just a matter of processing through. Now, right here, to find the derivative of the inverse function, we use the formula. Okay, so notice this is f inverse prime. So this is the derivative of the inverse, right? Derivative of the inverse, 1 over f prime of f inverse of x. So f inverse x subbed into the derivative of f. Again, it seems confusing, but when we break it down, it's plugging pieces into pieces. So thus, looks confusing, but once we use a little bit, it will start to make a little bit more sense. Now, before I get started, I do see a typo here. I have this scribbled out. It's not 0, 1. It is -1, 0. So before I even do anything, I see that scribbled out. Let me get it fixed here, right? Okay, here we go. The function f of x equals x cubed plus x minus 1 is a 1-to-1 function. Okay. Find the slope of the graph of the inverse function f inverse at the point -1, 0. Find the slope. What's that code for? Okay. So they say slope. Your calculus brain says, derivative of the inverse function at the point -1, 0. So that means we are using that formula, right? Now, we can't really jump into that formula right off the bat. Okay, I did this one 2 different ways. That's where I'm confused. Okay, sorry. I didn't look at my notes close enough, I guess, before I started. I'm going to take this one through 2 ways. Now, let's see. I'm going to start with our function is f of x equals x cubed plus x minus 1. I'm going to demonstrate this without using the formula. And then we're going to do it the other way, which is more using the formula. Okay? And we're going to gather some information along the way. So, if you have to find the inverse of that, first of all, what do we know f of x is? It's the same as y, isn't it? So this original equation is y equals x cubed plus x minus 1. How do I find inverse?
Switch the x's and y's.
Switch the x's and y's. So we're going to have x equals y cubed plus y minus 1. And this, of course, is the inverse, because we switched our x's and y's. Now, as we look at that, that's not one we can really solve for y, is it? Not easily. I don't know if we really have a method to do that at all or not. So there's a y cubed, there's a y. We can't really solve that. But we're being asked to find the derivative of the inverse. So we can't solve this for y, but we need to find the derivative here. And y's and x's are mixed in together.
We can differentiate.
Think implicit differentiation is what we call it. When you take the derivative of each term and you tack on the appropriate differential. Right? So the derivative of x is
dx.
1, and then tag on the dx, so that just makes it dx. Derivative of y cubed,
3y squared.
3y squared dy. The derivative of y, 1 dy. I don't know if you want the ones in there or not, but on that right, both terms have dy's, yes. So if you didn't already do it, I would factor out the dy. So I'm going to have a 3y squared plus 1 times the dy. So I rewrote that as dx equals 3y squared plus 1 times dy. What form do I want to put this in? I want dy dx. So if I want dy dx, I'm going to keep the dy here. I'm going to divide the dx over, which leaves me with a 1 over here. But then we also have to divide over the 3y squared plus 1, so this derivative is going to be 1 over 3y squared plus 1. And what is that? It is the derivative of the inverse. Okay? Now, that implicit differentiation wasn't horrible. Okay? Not the best, but not the worst. We were specifically asked to find, and I guess what I'm going to note here is, so if I use it instead of dy dx, if this is the derivative of the inverse, this is f inverse prime of x that equals 1 over 3y squared plus 1. We want to find the slope of the graph of the inverse at the point negative 1, 0. So plug in those values, right? So f inverse prime of, and for x we're putting negative 1. 1 over 3 times, what am I putting in for y? 0, because that's from the ordered pair. Yeah, it looks weird because we say we're putting in negative 1, but really was in terms of y, so we really put in 0. Do the math and we come up with one, correct? Now, that was not using the formula. That was the, basic, technically the long way around. And again, it depends. What kind of inverse do you have? How complicated is it? As in, sometimes the derivative of the inverse might not be that complicated. Other times, it's going to be more complicated to solve. So now, let's talk more about our formula. So we're asked to find the slope of the derivative of the inverse, right? So we're being asked to find f inverse prime. And we're being asked to find at what point? At negative 1, 0, right? So that's what we're being asked to find. F inverse prime of negative 1. Now, notice if we use the formula, look at the top. The formula says 1 over f prime of f inverse of what's x? Negative 1. That's your formula there. Now with a formula, or with all those parentheses, you always start where?
Inside.
The inside. F inverse of negative 1. This is given. What is F inverse, of negative 1? It's given in the original problem. 0? Mm-hmm. Because, didn't they give that right here? They're asking you to find the inverse at the point negative 1, 0. So F inverse of negative 1 is 0. So what am I going to replace that with on the bottom there? 0. So now this is going to be 1 over f prime of 0. So I took f inverse of negative 1 and replaced it with 0 because that's what our ordered pair said it was equal to, right? Now, we're doing 1 over f prime of 0. Well, did we ever find f prime of the original function? No, we didn't. Our original function was given as x cubed plus x minus 1. So what would f prime of x be? 3x squared plus 1. So if I come over here and put 0 in, it's 3 times 0 squared plus 1. And hey, does that sound a little familiar? It should. You end up here with 1 over 1, which is 1. Okay. I just did the same problem 2 different ways. Okay. The second way is the formula we're provided today. In other words, derivative of an inverse is 1 over the derivative of the inverse at the point. Okay. First one's not bad, but again, it's going to vary from problem to problem. And, how's the implicit differentiation look like? Questions I can answer.
What's a one-to-one function?
Yeah.
So 1-to-1 means it has an inverse. I was trying to think, is there another quality there also? We learned 1-to-1 back in algebra too. But basically, if a function is 1-to-1, basically it means it does have an inverse. Okay. It passes, I don't know if you guys remember learning the horizontal line test.
Yeah.
That's when we did 1-to-1, because the vertical line test says it's a function. The horizontal line test says it's also 1-to-1. So.
Say we did that at some point this year.
Did we?
The horizontal line test. I knew we had
It's
seen
possible.
one, right?
It's possible then. But yeah, that test for 1-to-1-ness. Okay.
I remember doing this here.
I can't guarantee. I'm going off what they say. I just know. I'm pretty sure it's an Algebra 2 topic is when I first introduced it.
It was super brief because we just had to do something. It had to be like, it had to pass the vertical line test for us to like do the equation or something like that. So that's we verification.
But did we talk horizontal line test?
I don't think so.
I don't remember talking about it.
We talked about
I seem to remember that, but I could be.
Yeah, I don't know. It blurs together for me, teaching 3 different things throughout, or actually 4 this year, but yeah. Okay, example 2. Let f of x equals x cubed plus x, and let h be the inverse function f. Find h prime of 2. Well, they're asking me to find h prime of 2, but what did they just say h is?
The inverse.
The inverse function. So they're basically asking me to find f inverse prime of 2, aren't they? If h is the inverse function, they're asking me to find f inverse prime of 2. I still don't know how to read that, sorry. It's easier to see it. So right there, beware, h is, I'm just writing this down, f inverse x. That's, given information there. I'm also going to write down my definition from above, in that f inverse prime equals 1 over f prime of f inverse of x. That's my formula. Now, officially, f inverse prime is the same thing as saying h prime, isn't it? So I'm actually, for the benefit of this problem, going to write this as h prime of x.
Shayla Towers Myers, please come to the middle school office.
what the heck?
That's some lovely echo, and I have no, wow. Okay,
She's in
so now, h prime of x, if I'm replacing f inverse with h, then this is going to be 1 over f prime of h of x, because the inverse is h of x, right? So just trying to get our proper notation here. Let's see, which way do I want to do this? F prime. Do we know F prime?
Yeah.
Not yet. Good answer. Can we find us an F prime? Sure can. If F is x cubed plus x, what is F prime? 3x squared plus 1. So, in my denominator, it's f prime evaluated at h of x. But f prime is 3x squared plus 1. So my denominator is, since it's f prime, it's going to be doing 3 times, wait a minute. Let's get that in the denominator. Sorry. My denominator, 1 over, is going to be 3 times something squared plus 1. What's that something going to be? Well, for the moment, until we figure it out, it's going to be, I'm just going to write it as h of x for the moment. Okay? Because we haven't talked about what that is. So for the moment, it's just going to be h of x. Now, at what point are we trying to find this? At 2. So let's switch over and talk about specific numbers, in that we are trying to find h prime of 2. Which means if I'm trying to find h prime of 2, it's 1 over 3 times this value squared plus 1. Which this is no longer going to be h of x that we're thinking about. It's going to be h of 2. Does that make sense when I say that? Because we're putting 2 in for x. I don't know if this is the best way to show the notation. We need to know h of 2, folks.
Which means we're gonna have to find the inverse.
Not exactly. We can avoid finding the inverse. How do I want to? We're trying to find h of 2. Then we're trying to find 2 comma something, right? Which can also be h of 2 equals question mark, right? Now, h is the inverse. If h is the inverse, that means this ordered pair for the inverse is 2 comma something. But for the original function, it would be, try again, something, comma 2, right? Like that's the idea of how inverses work. So the idea h of 2 something equals something is going to say the original function, f of something equals 2. And this is because we are talking about inverses. Do we have information that we could find f of something to equal 2?
You said equal to.
Yeah, so f is x cubed plus x equals 2. If x cubed plus x equals 2, can you do some basic math and tell me what x is? I wasn't going to really take time to solve it out, but basic math. Can I go with 1?
It has to be.
1 cubed plus 1 is 2. 1 plus 1 is 2. So can we agree by examination? That's what I want to use. By examination, we can agree that x is 1. Okay, because we're smart like that. Now, so what's this mean? This says that f of 1 is 2. If f of 1, so originally we said, okay, we went from there. If f of 1 is 2, what's this tell me?
H of 2.
That h of 2 equals 1. You see the kind of circle we went in there? So since we need to find h of 2, which is the inverse, right? We needed to find the inverse evaluated at 2. We found what the original function was equals, when the original function equals 2. So the idea that 2 comma 1 and the inverse is 1 comma 2. Or in the original it's 1 comma 2 and the inverse is 2 comma 1. So that means right down here, I did not leave myself enough room. Yikes. We're finishing this off right here, yes? It's 1 over 3 times, what's h of 2? 1. So 3 times 1 squared plus 1? Yes, 1/4. 1 squared is 1, times 3 is 3, plus 1 is 4. 1/4. We avoided finding the inverse that way. You do have to remember the relationship between the original function and the inverse function, though. The information is given there. You just have to find it, maybe. Is that a good word? Okay. There's no backside. I don't have any problems written out to sub. That seems odd. I would think there'd have to be something that has to be subbed out, but we don't have anything written down. So we're going to go with that. When you see derivative of the inverse function, or slope of the inverse function, work to try out this formula. You use it a handful of times, it becomes more routine. Okay?